Dear students, today we will see the electrical conductivity of acids. So here I have already prepared hydrochloric acid. This is a dropper and the beaker. Now I have set up the electrical conductivity circuit here. Normally it consists of a bulb battery. Okay. Now we'll see what happens when electricity passes through acids. Okay. So normally in acids, bases and salts lesson, this activity is there. So this activity can cover many types of questions. So I will cover those questions at the end of the video. Don't forget to like the video and watch the video till the end. Okay. So now I have added hydrochloric acid in the beaker. So now we will test the electrical conductivity through this hydrochloric acid solution. Now this is a battery. Now battery positive and negative wires. Now it is connected with the LED bulb. Now I am putting these two wires into the solution. Before that, just check whether it is working or not. It is glowing, right? When I am touching these two, it is glowing. So now we will keep these two wires in the water, in the hydrochloric acid solution. Now see, the bulb is glowing. Are you able to see? Now when I am taking out of the solution, it is not glowing. Now you see, it is glowing when the two wires are dipped into the solution. It means hydrochloric acid is allowing the electricity to pass through it. So HCl is a good conductor. Now I'll explain why hydrochloric acid is conducting electricity. What is responsible for the electric conductivity through this solution? Now we have checked with the acid, right? Next we'll check with the base. So now let me prepare sodium hydroxide solution. Now I have the sodium hydroxide pellets. Let me add distilled water in it. Now I have added distilled water. So now sodium hydroxide solution has prepared. Now we will test with the circuit. Now positive and negative wires are here. Now let me dip. Actually it is, you can see it is glowing. It is glowing because of something that are present. Now when I am taking out the wire out of this solution, it's not glowing. Okay, but when the two ends of wires are dipped in the solution, it is glowing. Means in acids and bases, there are some things which are conducting the electricity. Usually we call them as ions. So in acids and bases we have ions. They are responsible for the conductivity of electricity. So in the first case, when I took hydrochloric acid, now it is also a good conductor of electricity. Now sodium hydroxide is also a good conductor of electricity. Hydrochloric acid has H plus ions as a common ions. Okay, these are common in acids. If you take any acid, in all the acids, H plus ions are common. So each H plus ion is combined with one molecule of water. So it forms as a hydronium ion. So hydronium ions or H plus ions are present in acids. In bases, normally OH minus ions are there, and the respective metal positive ions are there. So this in these two we have ions. So ions are responsible for the conductivity of electricity. So okay, in the first case we have used hydrochloric acid. So now we are using acetic acid. This is a formula for acetic acid, CH3COOH. So now we will use acetic acid and we will do the same experiment. We will find what kind of result we get. Does the bulb glows again? What do you think? Now you are watching the video, right? Comment whether it will glow or not. If it glows, how it glows. So now I am adding acetic acid. Let me dilute it. Okay, so this is actually hydrochloric acid. I'm keeping it aside. So now again we will test the electrical conductivity of acetic acid. So we have seen that in hydrochloric acid the bulb is glowing brightly. So the brightness is more in that. Now we'll check what happens to the intensity of the light through the bulb when the wires are dipped into the acetic acid solution. Okay, so I'm struggling to keep. Okay, now you can see it is glowing. It is glowing, but observe the intensity of the light. So intensity of the light is not so satisfactory, right? So it is so less. It is glowing. Okay, so it means acetic acid is a good conductor of electricity. The bulb is glowing, but one thing, is it glowing with the same intensity as hydrochloric acid case? No, right? When the electricity is passing through hydrochloric acid solution, now this bulb was glowing bright, but when the electricity is passing through this acetic acid solution, the bulb is glowing with less intensity. So the main difference is the intensity difference. Usually what is happening, light is glowing means both are having ions, both are good conductors of electricity. But the thing is, in acetic acid the bulb is glowing with less intensity, and in the hydrochloric acid the bulb is glowing with high intensity. Can you guess the reason? Yes, here the concentration of H plus ions plays matter. Okay, here in hydrochloric acid H plus ion concentration is much, means more number of H plus ions are produced when HCl is added in water. But acetic acid, when acetic acid is mixed with water, it produces less number of ions. So because of this reason, means because of the less percentage of H plus ions in the solution, the electricity is not passing with good amount. So because of that, the acetic acid shows a dim in intensity of the light. Hope this is clear to you. Okay.